Okay, so in this problem we're looking at an empirical formula problem. We have a compound that we know is composed of a certain amount of nitrogen and a certain amount of oxygen, so in this case 3.5 grams of nitrogen and 7.98 grams of oxygen. And we have a molar mass that's around 95 grams per mole. The question is, what's the empirical and molecular formula of this? Note that a lot of times we'll start with a percentage here, so it would actually say the 3.50 grams would actually be given as a percent. And the 7.9, it would be some percentage nitrogen, some percentage oxygen. You would assume 100 grams and go straight to grams. In this case, we're given grams to start, so we're going to use that value. So the first thing we need to do is, for an empirical formula, it's comparing moles to moles. So we need to get out of grams and convert to moles. So I'm going to start with the 3.50 grams of nitrogen. And that 3.50 grams of nitrogen, I'm simply going to put to moles by doing 1 mole top and 14.01 grams, the molar mass of nitrogen on the bottom, and that's going to give me 0.249 moles of nitrogen. And then for the oxygen, I'm going to have 7.98 grams of oxygen, 1 mole, and then in this case we've got 16.00 grams, and we're going to get a value of 0.499 moles of oxygen. Now remember, an empirical formula is in the lowest whole number ratio, so what we're going to actually do is divide both of them by the smaller number of moles. So divide by 0.249 so that everything is relative to the moles of nitrogen. Divide by 0.249. And the first one is obviously going to equal 1 nitrogen, and in the second case, when you divide it through, you're going to get 2.004, which we're just going to sort of simplify down. It's easily close enough to round to 2 oxygen. Therefore, our empirical formula is NO2. Just make a little bit of extra room here. Okay, so since we have NO2, we need to know whether this is the actual answer or not. What we're going to do is we're going to take the NO2 and we're going to calculate the molar mass of that. So in this case, it would be 14.01 plus 2 times 16. So the molar mass of NO2 turns out to be 46.0, really 02, in that ballpark. So 46.0 is our molar mass of NO2, and we know that the molecular formula, the molar mass of the molecular formula we were given was 95 grams per mole. This could be found experimentally various ways. So if we take 95 grams per mole, we're divide that by 46 grams per mole. You can see that that comes out to be about 2. And so what does that really mean? Well, that really means that instead of NO2, which is about half as big as we need it to be, we're really dealing with probably the molecule of N2O4, okay, dinitrogen tetroxide. So N2O4 is our correct molecular formula here for this, and NO2 would be our correct empirical formula, and that's how you go from masses. Remember, again, if you were given an initial percentage, you just assume 100 grams, turn that straight into grams, and plug that in here and here, and you'll go through the same method, just turning it into moles.